We have been doing a lot of work with linear relations, but in order to continue that work, we're going to have to first review some algebraic skills. We're going to take a little break with linear relations and focus on some work with algebra. So what is algebra? I have a sentence here. Algebra uses symbols to represent information in a compact form. When you first started learning algebra, it's like learning a new language. You need to learn what the symbols mean and what it means when the symbols are combined in different ways. Let's look at this number sentence. It says 5 more than triple a number gives 23. You might be asked to write a mathematical equation for that number sentence and then solve it. And some of you might know how to do that already. But I really want to break it down so that we focus on what the symbols that we use in algebra mean. So when I break this down, I'm looking right here. There's a number that we don't know, okay? But we do know that if we triple that number, that's an important word, and we do 5 more than triple that number, we get an answer of 23. So all algebra does is uses symbols to represent those words. Let's start off with this word triple. What mathematical operation could you do to triple a number? To me, tripling a number is the same as multiplying it by 3. Okay, so that's an important word in this. The other part that to me is very important is when it says more than. When I see those words more than, I'm thinking that I need to add. And in this case, 5 more than. So maybe I want to write that as this, okay? 5 more than means to add 5. Okay. So let's go back and look at this again. I've got a number I don't know. Okay. A number I don't know. I'm going to put a question mark there. I'm going to triple that number. Okay. Which means multiply it by 3. And I want 5 more than triple that. So I'm going to add 5 to triple the number. And it gives me an answer of 23. My initial translation of this using symbols might look like this. 3 times some unknown number. That's tripling a number, okay? Plus 5, because I want 5 more than triple the number, gives 23. Okay? Now, algebra. Instead of using a question mark, algebra uses letters, and we call them variables, to represent unknown quantities. So the most common variables that are used in algebra are x and y. So right here, instead of this question mark, I might want to use an x. So I might write this as 3 times x plus 5 is equal to 23. And mathematicians didn't like how this part looked right here. The 3, a times sign is an x, and then we're using the variable x, okay? So instead of writing a times sign, and I know that we've talked about this before, mathematicians use brackets also to mean multiply. So when I write 3 bracket x and close the brackets, that means the same as multiply, okay? Plus 5 equals 23. And then they went one step further than that. And instead of writing 3 brackets, mathematicians decided that if we're just multiplying a number like 3 and a letter like x, we don't need the brackets there. Let's make it a little bit simpler and just write 3x plus 5 equals 23. So there is the algebraic equation that represents that number sentence. And I know I took a lot of time to go through there, but I really wanted you to understand, okay, what these symbols mean right here. X means an unknown. Putting a 3 in front of it means 3 times x, okay? Adding 5 equals 23, okay? Now, this whole thing right here that we've written is called an equation because it has an equal sign in it. If I just look at this part, okay, 3x plus 5, it's an algebraic expression. And that algebraic expression has two parts to it. It has the 3x part, and it has the plus 5 part. And those are called terms. Terms are the building blocks of algebraic expressions, so we want to focus on them for a little bit here. Here's the formal definition of a term, okay? A term is a number or a variable or the product of numbers and variables. So let's write some examples of terms. First part of the definition says a term is a number. So the number 5 is a term. The number -1 is a term. The number 0.25 is a term. Terms can just be numbers, okay? The second part of the definition says, or a variable. So a variable is a letter, right? So X is a term. Y is a term. Or M or N, whatever variable you want to use. Okay? Last part of the definition then. It says, or it's the product of numbers and variables. The word product means multiply. So we can multiply numbers and variables together and get a term. For example, we could have 2x. That's the product of a number 2 and a variable x. We could have -3y. That's the product of the number -3 and the variable y. We could multiply more than one variable together. We could have 2x, y. And when we write them all beside each other like that, it just means we're multiplying a 2 and an x and a y. Or we could multiply two variables that are the same together. So what if I took a 3, multiplied it by an x, and multiplied it by another x? Well, we don't write that, an x right beside an x. We know that exponents mean repeated multiplication. So 3 times x is the same as 3x squared. Okay? Let's go back here. The numbers. Another word for numbers is constants. Okay? They are terms, but they are also called constants because if they don't have a variable with them, their value is always the number itself. It never changes. The reason why we call letters variables is because we can put any number in for the variable. So the value of that term changes depending on the value of the variable. Changing means variable, okay? I don't know if you've ever used algebra tiles to represent algebraic expressions, but let's look at this X right here, okay? If you've used algebra tiles before, you might have drawn a rectangle, long skinny rectangle here, to represent an X, okay? And all that means is that the width of that rectangle right there is 1 unit wide and the length of that rectangle is unknown, x, so that the area of that whole rectangle is x. 1 times x is x. Okay? With algebra tiles, this 2x right here would be represented with 2 rectangles that are x's. Okay? So this diagram that I've just drawn there is using algebra tiles to represent 2x. So that number 2, yes, it means 2 times x, but it also tells us how many x's there are. Okay? And there's a name for the number in front of a variable. It's called the coefficient. It tells us how many x's are in that expression. Okay? I want to go back to this one right here. It looks like there's no number in front of that x, but how many x's are there if we just write an x? Well, there's 1. So often when we look at an x, we say it doesn't have a coefficient, but it actually does. It's 1. Okay? And now I just want to consider algebra tiles for an expression like an x squared. Okay? What would that look like? Well, an x squared, you remember, right here is an x times an x, right? So we've drawn a rectangle like this for an x. What happens if we do an x times an x? We could draw that like this. Here's an x, and we're going to times it by an x. So using array multiplication, what we get is a square, okay? So we would represent an x squared as a square that is x long and x wide. Okay, so this is an x squared tile right here. Okay, and if I had to represent 3x squared, I would actually draw 3 squares that are x squared in size. And I know mine aren't all exactly the same size, but they should be. Okay? So that's just focusing on what terms mean. Okay? And an algebraic expression is what we get when we combine terms together. So if I took a term like 3x squared and I added 2 x's to it, and then I added 5, this is called an algebraic expression. Okay? Taking terms and adding or subtracting them together gives us algebraic expressions. So, a little bit more terminology. There's another word for algebraic expressions, and it's this word polynomial. It means the same thing. An algebraic expression, we just saw the example on the previous slide of x squared or 3x squared plus 2x plus 5 is an algebraic expression. It's also called a polynomial, okay? And there are different types of polynomials depending on how many terms are in the polynomial. So if a polynomial has just one term, it's called a monomial. I've got some examples here. 3a, one term, okay, is a monomial. It's also just a term. 4b to the exponent 10 is a monomial. 5ab squared c is a monomial. Even though this last expression here has 1, 2, 3 variables, they're all multiplied together, so this is one term, okay? Terms are separated by adding or subtracting. So if I look at the second type of polynomial, it's called a binomial, and a binomial has two terms. So look at this expression right here in green. There is one term that's 4a and another term that's adding 2b. Okay, it's called a binomial. The next one here, the expression in blue, one of the terms is 12ab squared and the other term is to subtract 7. Two terms makes it a binomial. Okay, there's one other type of polynomial that we talk about, and that's if it has 3 terms, it's called a trinomial. Okay, look at the expression here in green. There's 5x squared, then subtract 3x, and then add 18, 3 terms. Okay, the other expression here in blue, ab squared is one term, adding 6b is another term, and subtracting 17 is another term. So there are 3 terms in that algebraic expression. So it could also be called a trinomial. Okay, and we don't go any higher than 3 terms with special names. If it has more than 3 terms, and you can have expressions that have more than 3 terms, maybe something like 4x cubed minus 3x squared plus 2x minus 1, that has 4 terms. It doesn't have a special name. It's just called a polynomial or just an algebraic expression. Okay, so I've got an example here where it asks you to classify each polynomial by the number of terms it has. If you want to pause the video right now and just answer the question, and then start it back up and we'll look at the answer. Looking at example A, I identified that there were 2 terms and therefore it was a binomial. Example B, I saw 1 term, so it was a monomial. And in example C, there were 3 terms, which makes it a trinomial. And I think that's a good spot to stop this video right now. And make sure we understand all the terminology involved with algebraic expressions. So if you understand that terminology, you can go on to the next video, okay, where we look at simplifying algebraic expressions. If you're still unsure of some of the terminology, maybe go back and watch the video again, and then reach out to me with any questions that you have.